Hello world, and this is the start, this is the beginning, this is video 0. I'm making this new series about this year's AQA skeleton code, which is Target Clear. I don't teach this year because I'm doing a cheeky PhD, but I managed to get my hands on the files, and so let's have a look at them. So we have, oh, I missed that, the whole preliminary material document, doesn't say much. The game file, and I made a copy. Um, Before I proceed further, let me disable the AI stuff they have put into Visual Studio Code, which is, I'm sure, very useful to program, but not super helpful for pedagogy because that won't be here when you're sitting the test, unless you're in a very, very bad exam center. No, it won't be here because yeah, it won't be here. And the first thing you notice about this, and many have in the computer science teachers community, is that it's not OOP, which is like, whoa, what's going on? Are you okay, AQA? What happened? And who knows? Maybe they plan to assess more OOP on the paper questions. So it's a possibility. Perhaps because it's an easier way to get for the candidates to get mark when it's assessed that way. Perhaps I've got my own theory, but let's not worry about this. The thing is that there's stuff to make up for the lack of OOP, as you kind of get into very quickly. Let's just play the game, not in debug mode, just the run. So Target Clear is a game, just a random game. It's a game where, make that bigger, hide that bar, even bigger, contrast is good. All right, so I need to shoot one of those numbers that are in a target gallery that's kind of moving right to left for you, right? Tick, 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 tick. And I can make algebraic arithmetic operations, so plus, minus, multiply, divide. And I've got 5 numbers, available numbers, the player numbers, that I can use for this. And I need to use an infix expression to do this. So here, what can I do? 5 times 6, 30. Let's start. That's a good start. 5 times 6, 30. Boom. It's removed the 30. There's a blank space in it, but you notice that everything has moved one inch to the right. So I need to get to take care of that 10. Maybe by doing 4 plus 6. No, it's not, don't like what I'm going on there. Actually, I mean, it's not a bad game, frankly. I mean, compared to what's been going on before, even some of them were pretty good, but they were underserved by their interface because you have to do everything with a keyboard. But this one, I gotta say, is the one that yes, well, to be fair, I have often said early when I discovered the skeleton code, oh, it's not a bad game until I kind of played it for a significant amount of time. But like, this is so simple, I don't see what thing. You get score per number you take off, meaning that the first time we got 1 because it was 1, but the next time when I did 10. It took care of 10 here and 10 there as well, right? Hence the whole. And that's why this score, well, actually, there's a bug. That's definitely, I found that already. That should be free because 1 plus 2. I will see why the bug is that you type an invalid expression, either because there's a space. So something that should work. Demo something that should work. 21, 6. 6 times 1, right? But if I type it 6 times 1 with some spaces, it doesn't work. And it's doctor point, right? So if you type something that's either doesn't pass or doesn't use the numbers or it uses numbers, it's a valid syntactical expression, but it doesn't match any of the targets, you lose a point. And that's the game. You lose when this number is here and you can't shoot it. So when it went past here and you win, I don't know if you ever win. It just keeps going on forever, I guess. I don't know. Not really looked that far, to be honest. Okay, we can probably zoom out a little bit. What I would like to do, so I have disabled the AI stuff, but not before I got an LLM to do something useful for once elsewhere, which I have right here. So I was asking Perplexity, you can use any old LLM. They're pretty good at doing this, right? So I've pasted the whole code because intellectual property be damned. I mean, to be fair, I got this file on the open internet. I was pointed to it by a very helpful gentleman, but ultimately that was there, and it was the site of a school, so it's not whatever. So I gave it the Python file, and I asked him to draw me a tree of the function hierarchy and their calls. So everything happened in the main. I'm gonna take that, which you can do in here, and then actually close this forever. Here, let's have us a new file of my structure.text, and paste it in just for reference. So main is the main game. Well, actually, main is the super function. Those are setup functions. GetTarget, that's just a wrapper. That's just a wrapper around random randint. I feel no precious about it. Yeah, okay. Ditto get number. Frankly, that wasn't necessary at all. Those will populate relevant arrays, so we initialize them. The playgame has got the main loop, which does a display state, which is still a free display function to display the contents of those arrays properly, and the score is just a number and a couple of line breaks. There's a validation function for the user input. That uses regular expression. So I think that might be the thing that is complex enough to make up for the lack of oops, is it has regular expression. I need to text my sixth formers because we're kind of gossiping about this and going, what's going on with this? Okay, so this is, so your infix, because Python, you could just do a function called eval, or eval, that will evaluate the a string you pass it, like the expression input by the player. So you could just literally verify this. Once you've checked that the numbers are allowed and the numbers are allowed, you could do the rest simply. But that would deprive us of the opportunity to connect infix expression to postfix expression, convert to RPN, which this is, so get number from user input is something that will use an index to actually get numbers rather than digits. So it keeps kind of grabbing, extracting it of the string. So it's kind of from that direction from where you are, right? It kind of moves as an index. You set it as an index, and then if it finds a digit, it will kind of keep on finding until it runs out of digits. So it will return the whole number, and it will return the pointer raised by however much. This comes up in a couple of places because it's quite useful. There's a lot of manipulation of strings into ints and vice versa, then checking all of this into a list. And sometimes a string is a string, sometimes it's like a list that contains things as strings. So it's kind of that might be also another challenge that compensates for the lack of OOP. Get numbers used are all in number allowed. That's quite self-explanatory. Check valid number. That's probably a wrapper around something stupid, but yeah. There's a lot of kind of really small utility functions that don't really need to be there. There's a lot of stuff that's done quite inelegantly, but also that means it gets done in exactly the same way in all of the languages, because there's 4 languages supported by AQA, as you know. And then we get evaluate RPN. So in order to check whether it's a target, the last thing, right? We check whether it's valid syntactically. We check whether if it's valid syntactically. We check whether we're only using the allowed or available numbers, and then we evaluate it as an RPN, and we check if this evaluation is one of the targets. Then we remove the targets. There's another ConvertToRPN here that's kind of just a bit ironic, but like I remember seeing this morning and thinking, but it made sense at the time. I'm not quite sure. I will explain that in a second. I will have a look. I'm going to have a look for this. Check value number again. It's kind of a wrapper on something, fill numbers, whatever. So what I would like to do, so I've made a copy called original, but like for my original, I'm going to make a copy and then rename this into annotated. Okay, so for below functions, I do them docstring style, so simply the main program. This is all init stuff. That's the number of targets. That's the length of the kind of row of the train of targets. That's a different max target. That's the max value for a target number, and that's the max value for a player. I'm going to use their terminology for an available, but also put mine in brackets. Player, player, not playet, player numero. All right. Okay. What about training game? The training game is here. So they can use test cases without randomness. So actually, the training game doesn't train you at anything because this parameter makes it much harder than the main game. Because started the training game and I was like, this is a terrible game, and in fact, it was not so bad. Right, the choice, whatever, you know this. Okay, this is all setting the training game. The main setup is that's the default, right? The default we have or max number is 10, so we can get a 10 as an available number, and the max for a target is 50. The max number of targets starts at 20. That's on both cases for the games. You notice they have much larger ones there, so that maybe they're gonna have some like support divisions. That could be like support divisions, like read. I'll tell you about how it moves, kind of handles divisions, because divisions could yield stuff that is not integer, and that's a way of them that they had to validate it. Um, So this is initialization essentially, right? This is where something is a little bit more interesting. So everything in here, we get two key lists, which are numbers allowed and target, which contains literally kind of this is target, this is numbers allowed. They each have their display function to print them pretty, but that's the list. Minus ones will be displayed as a blank space. But those two lists every time are being passed to functions, and then the functions return them. There's plenty of things that is done like this. Um, it's not strictly speaking purely functional for because it maintains state. It's got plenty of state, but it is properly procedural, if you will. Um, in that doing it like that means that there's no need, like the scope of the variable is well maintained, because like you come in, you're going to tell a function everything that it needs, all of the stuff it needs, whether it's for reading or for writing, from the upper scope. And then everything it may write to, you just get it to return to the calling scope, meaning that everything stays with the correct values. Otherwise, you would have to have global keywords everywhere. And that's why we have OOP, right? Like one of the possible intro for my unit on OOP is like kind of talk about scope, but yeah, whatever. Right. So this is just a helper function that populates the numbers, that passes the max number. The other one will pass the max target, and then PlayGame tells us into the main loop, right? I'm not going to really go over this one. That's kind of it's setup. PlayGame. Here we are. We start at 0, and then we are not in game over. And whilst we're not in game over, we get the main game loop. That's display, evidently, right? We read the input. Now, that's the first checking function. So let's have a look at what this does. And it does strictly a regular expression to say, so reading your regular expression, the caret, I don't know how much you might need to actually understand this regular expression to just get the gist of this, but it's true that unlike they don't have a refresher on regular expression syntax on their thing, whereas they have, like, say a copy of the assembly language, right, against the paper, because you're not expected to know that. Like, so, but like apparently if you're expected to know regex syntax, here we go. That means the start of the string. This is to group this. So let's just get a little bit of space. Right, okay, so we get no this is not the same thing. Okay, yeah. The start of the string, and then one or more types, one or more digits, and then it's double escape for reasons. But that means the set. This is a set, right? Like any of this character, this character, this character, or that character. Uh, Only once, right? There's no plus or star after this, so that just means one of these. But then this thing, the number and the operator, it needs to happen at least once, but can happen any number of times, once or more, meaning that you kind of build a chains of kind of things and operators. And then finally, you want a number, which is again one or more digits. So it to kind of like have your final thing. And if that's the case, so if search will just return a bunch of stuff, but like if it finds it, but like so that's why they tend to use like is not none to mean if we find this, meaning we've matched the regular expression has matched the input string, the input is valid, otherwise it's not. So we can go back to what is valid. Okay, then we're gonna have to. This is gonna be lovely. All right, let's dive into it. Convert to RPN, not this one, so we do that twice. Here it is. Okay, so that's an interesting one. Position is the index that we use to kind of read a character in the user input string. Precedence, well, I should actually comment that. I just said annotated and then I do the annotation verbally, but it's faster. Index at which we are looking in user input. This is a dictionary of precedence, of operators as key, precedence as value larger means evaluate first. This is something I can't read because of the bar, the operators. Now, this is it's kind of a buffer of operators with encounters. Now, get number from user input. This is the one I was telling you about. We all love this guy. What this does, you give it the string, you give it the position. The number is an empty string. You assume there are more digits to read because the first one you have some digits to read. So if, again, that's a search, right? You search for a digit and not is none. This is very good, right? Like not is none, that means that we have found something. Is not, so one place they've done it is not none, and the other one they said not is none. But that means the search returns something, meaning there is at this position, because there's just one character, we were able to find a digit. So what we do is we take the character in question, user input at index position, and we append it to the number. So we're building the number as a string. And we keep doing this as long as there are digits to read. If we find something that's not a digit, more digits becomes equal to false. But if not, if we continue, right, so we don't go there, and then every time we increment the position, and if we reach the end of the string as well, it means we kind of like the numbers were at the end of the string. We reach the end of the string, there's no more digits, we also escape the loop. So if at the end of this we have something in the number string, we return, we get nothing, we return -1. Huh. Yeah, meaning, that's going to be a problem for it, I think. Yes, so supporting spaces you can handle, but like I think, yeah, I've seen a couple of the tentative questions put on the wiki books. We'll find out, and we return the position. Otherwise, we return number, the string, the number we've built as a string. We cast as an integer, and the position. The reason for this is that we might go in saying, get me the number that's at index 3, but because it's a two-digit number, actually the next time the index needs to be at 5. We skip 4 because that was like the second part of the two-digit number. That's get number from user input. So this gives us the number as an int. I might kind of like, I'm not going to do type inting, but it's the number at the start. Because that's the first one. We do it one before we even start looping, right? So this number at the start returns it as an int. And next, new position. Okay. And then there's also initialize this empty list as because we build the RPN expression as we go along. So in which we will build right. So because we have the operand, we know that the first thing in the RPN stack, right? So that's a stack. So really it's the stack, meaning we're using append and pop. Pop by default, we pop the last element, append will append at the end, so that Python list behave as stack for this. And notice we return it as an integer, but we immediately cast it as a string to put it in that list of the conversion that we're building. And so that's one pass is effectively doing this. Because if you find because the first one we know it's a number, we know it's an operand. We don't have to do any fancy logic. We read it as an operand, which might break if there's a -1, but sorry about that later. That's going to break later on. Doesn't matter. And then we operators append, and then we assume whatever the next thing is an operator because that's the first one we've encountered. So position So we go in, all right, so if I get 2-digit and we start at 0, I can actually, let me put this. No, I'm gonna put a breakpoint, yeah, here to see what, when position comes back, because I would expect that, oh, I would expect that, debug, go, yeah, yeah, the Python debugger, because I want to debug the Python file. Random game. No, I need the other one, because this one will have big numbers. That's why it's important. Okay, so if I do 5, 1, 12 plus 3, so are we running or are we debugging here? Oh, because wasn't valid? It didn't go into the ConvertToRPN by the looks of it, or? Ah, okay, I'm struggling here. Fine, but let's assume that for some, okay, so if we go, if my 5, 1, 12, the 5 would have been at 0. I need to look at the other one. Get, right, so I'm going to zoom out a bit here. Forgive me. We increment, oh, I see what's happening. All right, okay. So even if more digits is false, right, we'll increment here. We really, this should kind of live here so that we only do it in the right conditions. But it does happen. Position is always going to be incremented a little bit more than it should, which is why, because this line's not in the right place, which we could probably annotate. If this was after number plus equal dot dot dot, we have to call. No shade. No, but they write them broken on purpose, I'm sure. Well, at least partially. Um, right. So that's why the -1, right? So we know we've got an operand. We know the next thing is an operator. Um, remember, this has already been validated that we've got nothing but like kind of a number, an operator, another number, and potentially another operator and number pairs. Like that. So we know that there's no space, there's no character we don't expect. Right? So definitely the first one was an operand, it was a number. We got it as an int. We've casted it back as a string before putting it into a little RPN expression stack, because we'll evaluate that in another function later on. And now we know that we have an operator. So we build that kind of queue of operators because we don't know what is going to apply to, because it might be that, by precedence, um, we only find out what it's going to apply to, in fact, when we execute the thing, actually, because there's no way, we don't use eval. So as you type it, it's just a string. And like at this stage, we don't know that there might be a multiplied further down the expression that needs to be run first in maths before your plus can do anything. So my plus will go in there. And then whilst we're not at the end, right, continue the thing, we do the same thing as this. So reads again. Let's mark this as 1. Well, we can mark this one as 1. Then we reach the next stops. Operator up or yeah, operator operand. Now, if we're not at the end, having done this, remember this increments position, but this doesn't. No, if we're not at the end, so if there is, that's the thing. If we should reject at prior validation anything that ends by a plus. So if we're not at the end, the current operator is the one is literally the just kind of that's the final operator, right? You only know you're at the top of the tree essentially, right? And you can only start doing kind of the expression's complete, and it always ends because it's in postfix. It always ends by an operator. So that's the current operator, and it's the first one that comes out of the stack. So once the length of operator, right? So we put this is the current operator. We don't even put it into operators. Once there are operators in operators, and the precedence of the operator is larger, we are going to append it to the okay, so like we do an operand, then we repeat with the next operator, and then the current operator, what do we do? So we don't put in operators there, but if there are things with a higher precedence there, we do put it in there. However, if the precedence is equivalent, we also put it in the RPM input. I'm gonna need to read that a bit slowly. Oh no, okay, right. No. User input in RPN append. Oh no, sorry. I see what's going on there. We pop. I'm not reading the same thing. If our current operator is of smaller precedence, right, than the one we have at the front, the top of operators, we get the last element, and we pop it. So that pop should really be in here. That pop should really be in here. So if they're of if the if the current operator is of lower precedence than the operators we have at the top, we pop it and we instead put it onto the RPN list we are building. And in all cases, we don't do that. We don't do that if the current operator is of higher precedence, needs to be done first. But in all cases, we append the current operator. So that means that it's going to come after the ones that he beats in terms of precedence, meaning it's going to be evaluated kind of, first or last, I guess, probably. Whereas, depending on which one you look at it, um, but um, but only in some cases it will be the one that it will have the other one will not be in the stack of operators there. So it's ultimately we kind of going to acquire yeah. So like if I've got plus already in there and no okay, if I get a plus in there and I come in with a multiply, let me get that right. The precedence of the multiply is larger, which means we're going to stick it on top of the plus in the operator stack, right? Not in the RPM expression. If I come in with a plus and there's a multiply on top of the operator stack, we take the multiply, put into the RPN stack, and then we add the plus onto the operator stacks. Else, that means if we are at the end of the user input, as long as there are operators in our stack, we just kind of destack them, we append them, popping them. So in reverse order that which they were popped, they were pushed. We put them into the expression, meaning that the first thing you've put at the bottom of the stack, if it was like a low order operation, will or lower that will come after, will come back and be the first thing, the kind of the last thing to get done. Or the last thing to get transferred to the RPN expression, and probably the last thing to get done because they evaluated in order. Whew. Right, now we've turned it into an RPM. That's nothing about the evaluation. Oh my god. Okay. I don't know if that explains it, because I should have really kind of put comments. I can not have to do that again to myself, because that's what we should put comment. I say we, it's all of you, really more you than me, but really me first, because I should set an example. Right, so we've converted it to an RPN. We now put the user input in the RPM, and then we check numbers used are all in numbers allowed. So remember, in the RPN, the numbers used are still as stringed. We as string, not as integer. But this is just a simple check, shouldn't be too difficult. There's a temporary array. We put all of the numbers in numbers allowed into the temporary array. So the numbers allowed, you're only allowed to use them once. So I can't do two multiply two because I get two twos, but I can't do 3 multiply 3 because I only get one. So we put the numbers allowed into temporary array, and we're gonna append the items that are in the expressions. So that's how we populate the temporary array, and then for each of these items in there, we check that it's a number, and then we remove it from the temp if we check it's a valid number, so that's kind of it's below the max number, and we check it's in temp, so we check what's in the copy of numbers allowed, and if it's in temp, it's allowed, but now we remove it, so if you get a second one, you can't have it, and that's going to depend. So if we manage to get through that, we return true. Otherwise, if you use the same number twice, essentially, you return false. That's all that it does. I should probably put it there, right? Well, it's like checks there. The most important bit is more like the checking that you can't use the same number twice. And then if that's the case, so we're at the end. Well, no, at the end. So that was the first check. The second check is does it evaluate as a target? And this is where the figure magic is going to get the RPN expression is going to get evaluated, right? Check if number as a target, evaluate RPN. Let's stop the debugger. Okay, so we've done this. Target, not that target. Didn't pick the easiest. Wow, that's a mouthful. And in camel case as well, because that's AQA. But again, it's the consistency across the languages, right? So targets, user input and RPM score. So we evaluate the RPN, and then we assume it to be false. And user input evaluation, if we couldn't evaluate the RPN, no, if we could evaluate the RPN, that is different from -1, then for each of, we iterate over target, and if what we've calculated matches one of the target, we add 2 to the score, and we put a -1 for that target, which is going to be a blank. And then we will return true. So we will return true if it hits 1, but we remove all of them. And for all of them, we had 2 points. The reason we had 2 points is that in the main loop, by default, if we're not able to, because there's no else's there to say something was invalid, we're always subtracting 1. So the idea is that if you shoot a target, you get 2, because you want to get 1, but because you're going to be subtracting 1, we give you 2 in the function underneath, so that it reverts back to 1. The problem with this is that when you actually get to shoot several targets with the same expression, you end up with like 2 times the number of targets -1, which is not exactly n, right? Like 2n minus 1 is only equal to n for n equal 1. So that works very well when you're sniping them one by one, not so much when you're scattershotting. So that was the easy part. The harder part is this. I'm just not relishing this. All right, so we get a stack. Whilst we've got something to read in the RPN, and what we've got at the front is not an operator. We're just gonna append. We're gonna pop what's in the RPN expression, and we append it to the evaluation stack. And then once we finish with that, it means that what we've got at the top is an operator. So we pop the first one, the top of the stack as num2. Then we top the new top of the stack as num1, set 0.0, that initializes a float, the type float 0. That's important because then you can do some math later on, because sometimes because of the divide you may not end up on an integer. So we've pushed, what am I doing? So we've now popped the 2. We know that at the top of the RPN expression stack is the operator we're going to use, and we've kind of put the 2 numbers, num1, num2, and then we've got this big ugly if-elif structure that's just like num1 plus num2, num1 minus num2, etc. Once we've got this, we pop the operator, and then we cast the result to a string because yeah, why not? No, of course, yeah, we have it's part of the game, casting back and forth, and then we append that to the evaluation stack because then we keep on reading, and what we've just calculated might become it's a number is going to become could become an operand of a later expression. If, right, so that's inside the while. No, so that's outside the while. So we've done all of this, and then at the end, hopefully, we've read everything. Now, this is the crucial moment, right? If to at this stage, yeah, this is more than annotating. Well, it is annotating, but like I'm actually going to insert a comment line rather um, than add it right next to it. If we've reached when we've reached this stage, because we're pretty confident everything has been like super clean and validated. When we reach this S0, the top of the stack, contains the result. But if the result I'm pretty sure maths floor will. Does maths floor return? Probably returns it as a number, returns it. But essentially, if the results had decimal points, the expression was invalid. So we know this already. We're not going to return something like 42.22222 because to do a usage check is 42.2222 into a list that only contains integers, right? We know we only have integers in the list. But like we can get. So the evaluation will also do a validation as to whether it's the target. So where was EvaluateRPN called? It was called here. So we evaluate this. We get a user input evaluation. If it's valid, so if it's not valid, we return -1 and the new score. And the new score is going to be, which is an untouched score that gets by default decreased to -1. Um, but if it is not -1, if it is the real value, we find it in the list of target. I've just explained this function already. Actually, I realized I saved the thing. So we've done this. I'm a bit tired. Okay, so we've done this. We've done this. Right now, finally, this is a boolean that, like. So if we have a bool, we remove the numbers used. So that's kind of like, same deal, right? Because you add the user input and you add the numbers allowed. It extracts all of the numbers from this, and fill numbers will replace those by you pass the training game flag. Because did you have to pass the training game flag to play then? Yeah, because you get it in main. Fair enough. So again, it's whether you fill the number. So the training game will fill specific numbers, right? And the max number is because you validate as well. Because if you're not using the training game, you're using randint, and that's the maximum number, right? And so this is the first bug, right? We decrement the score by 1 and attempt to increment it by 2 when you get a hit, which is cool, unless you get more than a hit at once. And then, this is important, this is after the print. We've done all of the stuff. If it's here, you could have yeah, we're gonna update targets, which like real quick, we'll just shift them by 1, right? So count is equal to target count plus 1. No, that can't be right. It should be the other way around. Oh, maybe they're not displayed. Okay, so for iterating over targets, what is the target as count becomes equal to, oh yeah, what is the target as count becomes equal to what used to be in target in front of it. So we kind of move everything back. We also pop, meaning we move the last element. But then we append a new one. So in training game, the training game never ends. So we kind of like reappend the one that's at the front. No, that's annoying. We append the one that's at the back. So we just kind of fill it up with the same one that was the last one, weirdly. Whereas this one will fill it up with new random number. Okay, fill with new random targets. Fill with the last element, the previous element, but the current last element, essentially, because the last element might not be the same last element. This will cycle the list forward and Well, I don't need to comment them all of them, but okay. Well, I think we got a good idea of essentially this. I've not annotated it as much as I should have, really, but that's my problem. Um, I don't need to, but if you want to, I don't know, because like you won't have annotations in the on the day, but maybe that could help you try and figure out like where things are. Maybe have a separate file that's annotated and work, train yourself onto a plain one. That's why I always keep several copies. Um, so I think, I mean, my prognosis stuff that's interesting to do here, supporting brackets is not only, I mean, really that functionally changes the game because you can actually like do many more expressions if you're able to list them not in the order that they happen. Um, Maybe supporting white space. Brackets would be really interesting because you need to check their opening and closing and the like, but that might be a bit too interesting and too spicy. White space, that's a trivial one. Allowing numbers to be reused could actually, as we've seen, let me just kind of look at you directly. I'll get a little swipe effect. Yeah, so as we've seen, allowing numbers to be reused would be mainly actually removing some bit of the existing code, but maybe the logic would be checking that it works as well. I don't know. This is one where I'm less, not that I was I felt I was kind of confident. Well, once I'd spent some time with the code base, which isn't the case today, but I thought last year I was kind of again a good idea what they could be asking. But I also need to have a look at the EAD, which we'll do together. Of course, there'll be a video about this to see Wagwan as the youth are saying these days. I think that's a clear sign. It is time for me to wrap this 41 minutes video now. Thank you for watching. The next one's going to be shorter, and I'm going to go through the tasks on Wikibooks, unless someone wants to send me some zigzag tasks. Wink.